Hi, this is Lori, and this is my homework / walkthrough for the Cogsworth City Kit. This covers the Day 2 adventure. I just want to remind everybody I'm not sponsored. I purchased this kit myself, and I'm making these videos for myself, and maybe some other people might find them useful as well. Well, as I go through lessons like the one for Cogsworth City Kit, I always wonder, why am I doing certain things? Why am I putting certain components onto the breadboard? And one of the things we did for the Day 1 adventure was blink an LED. And when we put that circuit together, we were told to put a 220 ohm resistor with our LED to limit the current going through it. So you can do that, and then you, for me, I sit there and wonder, how did they know that 220 ohm resistor was the right one? There's 4 different resistors in the pack. How come we chose to use that one? And so when I first learned this concept, I wrote it down, and I thought I would just share how that works. So we use a Ohm's law, and it tells us that voltage equals the current times the resistance, and it can be symbolized here by these letters. And so we're interested in resistance, so we'll turn around this equation and say resistance equals voltage over current. And then we need to know some things about our specific setup. So we're using the Hero board, and the pins deliver 5 volts. So when we turn it on to high, it's delivering 5 volts into our circuit with our LED. And then we need to know something about the LEDs themselves. Now can be a little bit difficult because there's not really what's called a data sheet for most LEDs that we get in a kit. We really don't know what the forward voltage or voltage drop of that LED is. That's a property of the LED. And it does vary with the colors usually. And I would say when I have been able to tell what it is, it's somewhere around 1.5 up to maybe 2.5, depending on the color of the LED. 1.8 volts is probably a reasonable number to put in for the voltage drop across our LED. You could put in different ones and see how this affects the calculation. And then typically these LEDs have a maximum current rating of about 20 milliamps. So we'll use that for the current. And again, these are things that I just learned from kind of Googling around when I was trying to learn how people knew what resistor to use. And I'll also say I'm not an electrical engineer or an electrician. I've been just learning this as a hobby. So, that's just important to know. I'm not an expert. But anyways, we'll use those values to calculate the resistance, and it would tell us that we should use a resistance of 160 ohms. And resistors only come in certain levels of resistance. So the 220 ohm resistor is probably the closest to that. And it's probably better to use more resistance than what we calculated than less. If we use too little resistance, what will happen is that LED will burn out. So that's why we have the 220 ohm resistors included in our kit. And that's how they knew which one to use. And if you want to learn more about LEDs, there's some good sites here that I read to learn more about them. So that's how I learned how we pick the resistor for our LED. All right, so in Day 2, we're going to use a push button switch, sometimes called a momentary switch. I've also heard it called a tactile switch. And a switch just controls the flow of current through our circuit, and it can either be open or closed. Open is when the switch is not pressed, and closed is when it is pressed. And here you can see one of these typical buttons like we have in our kit taken apart. And you can just see that what happens when we press on it is we connect both sides of the button to each other, and it allows the current to flow through. Now here, when you look at the buttons, they have these kind of crooked legs, and the 2 legs that point toward each other two pairs of legs that point towards each other are connected inside this button. And then when we press it, we close this side and we create a circuit and allow it to the current to flow through the button. So in this diagram, you can see that B and C are connected to each other and A and D are connected to each other. And this represents the pushing. When we push that button down, we move that line and complete the circuit and allow it to flow from one side of the button to the other side of the button. And that's a little bit about why we place it as we do on the breadboard. So that's a little bit about buttons. Now this is the circuit diagram, the wiring diagram for day 2. So we have our LED connected in with our current limiting resistor. And then you see our button switch on here, and you'll notice these little green lines. Those are the two sides of the button with the little legs that are pointing toward each other that are connected, and that's what these green lines are kind of showing, is that this side of the button connects this part to this part because we're going across the trench of our breadboard. And then same thing on this side. So we can't connect these rows to these rows until we press the button. And here's what's called a pull down resistor, and there's no explanation of this in the lesson. We're just told to hook it up that way. I do believe I think there's some other places in the lessons for the whole site that talk about resistors, and there might be a place that talks about pull down and pull up resistors. But this is the resistor that I'm now going to talk about on the next slide. So what is the point of that resistor on one side of our button? And the one that is shown in the day 2 wiring diagram is called a pull down resistor. And but there's also another version of that could be done as what also called a pull up resistor. And so they're used to manage the voltage on the pins from our hero board. So when the pins don't have any input condition coming to them, they do have a little bit of voltage on them, and it flickers. And so to make sure that it's quiet, that the voltage isn't flickering, you put in this pull down or pull up resistor to either pull the circuit down to low or almost 0 volts, or you can pull it up to high or almost 5 volts. And so that's the difference, pull down or pull up. So in our wiring diagram for day 2, we put in a pull down resistor because that resistor was connected into ground, and then we connected in our jumper wire that goes to our pin on our hero board, and then we go to the switch, and the other side of the switch is connected to power. So that's the pull down. And later on in some of these days, I'm going to actually use what's called a pull up resistor, and that is where the resistor is connected to the voltage. So it pulls it up to high when there's no input on the pin, and then we connect into our pin on our hero board. We go to the switch, and then the other side of the switch will be connected to ground. So I found this diagram as I've been learning electronics very useful, because I tend to get them, I tend to forget how they work, and so I always come back to this diagram to remember how to either connect up a pull down or a pull up resistor. Okay, so I have the code for day 2 up on the screen, as well as you can see my setup for my hero board and breadboard. So we have our LED set up as we did before, and now we have the button put on here, and I'm straddling the trench here, and this is the side that is connected on either side of the button, and then we would connect these two sides when we press the button. So you can see here's our pin coming back to our hero board, our jumper wire that's connecting to the pin on our hero board, and here's that pull down resistor. It's connected in here to the ground rail, and then the other side of the button is connected into power. So this one is a button with a pull down resistor. And so let's just take a quick look at the code. Yeah, I didn't really do anything different than than I think is in the code. So we have our LED on pin 13, and I have the button connected to pin 2. And then we create this variable called button state to track whether the button has been pressed or not. And because we're using the pull down, when the button is not pressed, it will currently read low. And then when we press it, the button will read high. So we'll need to set up our LED like we did in day 1. And then we'll set up the button as well. And then notice that the button gets set up as an input. And then I just reminded you that when we use this external pull down resistor, pressed equals high and not pressed equals low. And then in the loop, we'll read the button state using the digital read. And if it's high, meaning it's pressed, then we're going to turn on our LED. And otherwise, it must be low and we want the LED off. So it's pretty simple. So yeah, I already have it loaded in, so I'll just press and we'll see that the LED comes on. And it comes on as long as we have it pressed, and as soon as we let go, we break the circuit and it goes off. Yeah, so that works pretty well. And that's a fun little exercise. And that was the work that we needed to do for the day 2 adventure. And as always, I want to thank you for watching, and I'm hoping somebody else maybe is finding this valuable. Till next time, see you.